Hello friends, today in this part of program we will see the comparative study of the various microprocessors like 8086, 8088, 80186, 80286, then 386, 486 and some more. Now let us see what the actually microprocessor is. As we all know, it is a multi-purpose, programmable, clock-driven, register-based device that reads the instructions from memory. It accepts the data from the memory and then it processes the data according to instructions and provide the result. There are different types of microprocessor which have been developed till date. Now let us see the basic microprocessors which were developed at the initial phase. First was the 4004. It was developed in 1971. It was a 4-bit p-channel MOSFET technology microprocessor. Then came the 4096, again a 4-bit processor. It was having 45 instructions which were executed at 50 kIPS, that is 50 kilo instructions per second. Then with the advancement in 1972, the next processor came, that was 8008. It was the first 8-bit processor and it was using 16 kilobytes of memory. Then came the 8080. It was developed in the year 1973. It was the first 8-bit microprocessor with few advanced instructions. Then it was TTL compatible and the advantage was that it can use 64 kilobyte of memory. One of the first microcomputer, that was MITS, it made use of this processor. Then came the 8085 microprocessor, that is the Intel 8085 microprocessor. It was using the clock generator and system controller. The modern microprocessors which are used nowadays is 16-bit, 32-bit, 64-bit. The 16-bit first microprocessor was 8086, developed in 1978, and 8088, that was developed in 1979. The 32-bit microprocessors are 80386, 80486, and the Pentium processors which we are using nowadays are using 64-bit data bus. Then there is another term, microcontroller. It is nothing but a single chip microcomputer. It has in it the address bus, the data bus, along with it, it also has the memory in it. It also has ports in it and it also has some interfacing chips like the DMA or the PIC within the controller. Then came the parallel processors. They are also known as the gigaflops, that is GFLOPS. These are actually the Hydra cubes. Arrangement of processors is done in the form of a dimensional cube. Then we are also nowadays using DSP processors, that is digital signal processors. They are responsible for performing the various complex mathematical operations. Then some important terms before going for the differences in detail are also being discussed. One term is the RISC, RISC. It stands for Reduced Instruction Set Computer. If a processor is a RISC processor, then its instruction set is less complex, or we can say it uses the instructions which are less as 128 instructions. That means in RISC processor the number of instructions available are not more than 128. Then we have CISC processor, CISC. It stands for Complex Instruction Set Computer. It has large number of instructions, the variable length instructions, multiple addressing modes. Addressing modes means the method by which we define the operand for the instruction. A small number of internal process registers, the instructions that require multiple number of clock cycles to execute. The Intel's 860 is a RISC processor. It has 82 instructions, each 32-bit in length. it uses 4 different addressing modes, it uses 32 general purpose registers. All instructions are executed in one clock cycle. Now, this is the diagram which shows the various processors which have been developed till date along with their data bus width and the memory size. The memory size means the memory size or the external memory which can be connected to these processors. Like it has 8085, it has data bus of 8 bit, external memory is 64K. Then 8086, its data bus is 16 bit, external memory is 1 megabyte. Then 8088, data bus is 8 bit, external memory is 1 megabyte, and so on. The number of processors along with their data bus size and memory size have been shown in this diagram. Now again, this is a comparison table in which the various processors, their year of the manufacturing, their number of transistors used in it, the external data bus size, then internal register width, all have been given in detail in this block. Now let us come to the processor 8086 and its main features. The 8086 was developed in the year 1978. It uses 20-bit address bus. It can access 1 megabyte of memory externally using the address bus of 20 bit. It has the instructions over 20,000 variations. A separate BIU and EU is available in 8086. The 8086 architecture is majorly divided into two components. One is the bus interface unit and another is the EU, that is the execution unit. Bus interface unit is responsible for the interfacing of address bus and data bus, and execution unit is responsible for performing the various arithmetic and logical operations. Then it has 16-bit internal process registers. The various registers of 86 are AX, BX, CX, DX, then CS, DS, ES, SS. Then it has the index registers like SI, DI and all that. It has hardware multiply and divide built in. Then supports for external math processor. We can connect a external math processor to 8086. This diagram shows the basic block or the basic internal architecture of 8086. As we can see, the architecture is divided into two components, bus interface unit and the execution unit. The execution unit has the ALU and the registers. The bus interface unit has 6-byte prefetch queue, then a adder circuit to calculate the 20-bit physical address, then it has the various segment registers and the instruction pointer register. Then this diagram shows how the execution is carried out in the 8086 microprocessor. As we all know, 8086 supports the pipelining, that means the parallel execution and fetching of the next instruction can be carried out in the 8086. Now let us see some features of 8088 microprocessor. As we know, 8086 advanced version is 8088. It also has 16-bit data bus. 8088 can perform 16-bit operation but with the help of 8-bit data bus. That means in 8086 we were directly accessing the 16-bit data, but in case of 8088 the operation internal carried out is of 16-bit, but the 8-bit data is read first as the lower byte and then again 8-bit data is read as the higher byte. The 8088 can access 64K memory in the expandable mode, but in general it can access 16K memory only. Its clock frequency is 4.77 megahertz. Now let us see some features of 80186 and 80188. It is high integration CPU. The schematic for IBM original PC was using this 80186 and 80188. It is using the basics of 8088 microprocessor. but it has several additional chips which are added. The 80186 is nothing but 8086 plus several additional chips. Added 9 new instructions, then it has a clock generator, it has a programmable timer. Again, the timer is used for generating the delay ranging from few microseconds to hours. It has programmable interrupt controller, that means the 80186 has inbuilt feature of programmable interrupt controller PIC. It has the circuitry to select the IO devices. Now this is the basic block diagram for 80186. Again we can see it has the bus interface unit, it has the execution unit, but the calculation method of the address is somewhat different from that of the 8086. It also having the clock generator, it has a 16-bit ALU, it has chip select unit of its own. Now we come to the next processor, that is 80286. This 80286 was developed in the year 1982. The instruction set is powerful as compared to the previous processors. Some instructions executed in 250 nanoseconds. The overall speed is 4 MIPS, that is 4 mega instructions per second at the clock frequency of 8 megahertz. 24-bit address bus. The address lines have been increased as compared to the previous processors. It can access 16 megabyte of memory. It was using additional 16 new instructions. It works in a real mode, that is first powered on mode. The functions are more or less same as the 8086 microprocessor. Uses only its 20 least significant address lines for accessing 1 megabyte of memory. It also supports fatal flow. Once it is switched to the protected mode, it is not able to switch back to the real mode. 286 chips are operated in real mode and thus function only as fast as 8086. The IBM 80, that is IBM Advanced Technology Computer, uses this 80286 processor. Now this is the basic block diagram of 80286 processor. Again we can see the physical address is calculated with the help of the offset address and the segment address. As we all know, the physical address calculation is done with the help of two registers, that is the offset register and the segment register. Then this 80286 has its own address lines, latches and drivers. Then it uses its own bus controller. Then it has data transceivers, that is data transmission and reception is controlled by this block. Then it has 6-byte prefetch queue, as we have seen the queue in 8086 processor also. Now after this 80286, next processor came into existence was 80386. It is a flexible 32-bit microprocessor. It was developed in the year 1986. It was having its own data bus and registers. It has very large address space as it uses 32-bit of the address bus. Using this 32-bit address bus, it can access about 4 gigabyte of physical memory, a huge amount of memory. 64 terabyte of virtual memory using the virtual memory concept. Then 4G maximum segment size. 4G maximum segment size means a single segment can have the maximum size of 4 gigabyte. Then it has integrated memory management unit. Integrated memory management unit was first time used in 80386. It uses 4 level of protection. In this 80386, new 16 instructions were added. It supports again the real mode and the protected mode. The virtual 8086 mode is available in 80386. Now what is this virtual mode? The virtual memory or the virtual mode means like we have a program whose size is much bigger than the memory size of the processor, and we want to run this program or the application. So, this memory management unit performs a task that the whole program is divided into the small segments, like we are having a program whose size is say 1 kilobyte, but the available memory is say 256 bytes only. So, what is done is that this whole program of 1 kilobyte is divided into the segments of 256 bytes, and at a time if one segment is executed, and once the segment is executed, this segment is removed and the next segment is brought for the execution. So, for the user it seems that a bigger size program have been executed using the smaller size memory. This is the virtual memory concept. This feature was available in 80386. Now, the various options of 386 are 386SX, then 386EX. This 386SX, it has 16-bit external data bus, 24-bit address bus, and 386EX has 16-bit external data bus and 26-bit address bus. Now, this is the basic block diagram for 80386. Again, it is having its ALU, its register, its instruction decoder and sequencing, decoded instruction queue, then it is having page cache, control unit, then it has its own limits and access rights. The memory management unit is responsible for controlling the virtual memory concept. After the 80386, next processor came into existence was 80486. The Intel released 80486 in the year 1989, maintaining the compatibility standards, that is, it was compatible with 8086, 286 and 386. It was polished and refined 386, and it was twice as fast as compared to 80386. Redesigned using RISC concept. Then frequently used instructions were having a single clock operation. It was having a new 5-stage execution pipeline. So, in 80486, the pipelining concept was raised to 5th level. That means, in earlier stage we were having a single pipeline, but as with the increase in the technology, as we came with 80486, we were having the 5-stage pipelining. Then it is highly integrated. It is also having the 8 kilobyte of memory, cache memory. Cache memory acts as the high speed buffer between the main memory and the external memory. Now, it also supports floating point processor. It added 6 new instructions which were used by the OS. Now, this is the block diagram of 80486. Again, we can see the various components of 80486, that is its registers, its ALU, its control units, its 32 byte queue. It is using 32 bytes of queue. At the earlier stage in 8086, we were having only 6 byte queue, and now in 80486 we are having 32 byte queue. So, the processing speed will be raised to a greater extent. Now, let us see some more features of 80486. The various options in 80486 are 486SX for low end applications that do not require coprocessor or internal cache. The clock speed limit is 33 megahertz. Then we have 486DX2 and 486DX4. The internal clock rate is twice or 3 times the external clock rate. The 486DX4, it has internal clock frequency of 100 megahertz and external of 33 megahertz. Then 8086 also had some overdrive processors, that is 486DX2 or DX4 chips with overdrive socket pinouts can work with even more high speed. To upgrade the low speed, the 486DX SX with 486DX2 and DX4 can be used. After the evolution of 80486, the next development started, and the new era came of the Pentium processors. It has the increased with the complexity of the IC. To scale the chip down, it also has more complex network as compared to the previous processors. It is also known as the super scaler, that it supports 2 instructions pipelining with 5 stage. ALU address generation circuits, data cache interfaces are available in Pentium processor. Actually, it can execute 2 different instructions simultaneously. The Pentium processor has the capability to process or to execute the 2 instructions simultaneously. The Pentium was developed in the year 1993, originally labeled as P5 or 80586. Earlier its name was 80586 and then the name given was the Pentium. It works on 66 megahertz of clock frequency. As the clock frequency is increasing, the processing speed also increases. As we know, the T is inversely proportional to F. So, if the frequency is increasing, execution time is decreasing. It uses 8 kilo of code cache, it uses 8 kilo of data cache. That means there is a separate cache memory or a high speed buffer for code and there is a separate high speed buffer for the data. External data bus is of around 64 bit. That means the word length has raised from 4 bit to 64 bit. That means 64 bit data can be processed in parallel at a time. It also added 6 new instructions for used by the operating system. Then let us see the basic block diagram of Pentium processor. Again we can see it has the same components, that is the registers, ALU, adder circuits, 32 byte prefetch queue and similar type of 2 blocks are available in this architecture of Pentium processor. Earlier we were having only 32 byte queue, one stage. Now in Pentium processor we are having 32 byte queue and 2 stages. Then it also has the 8K data cache and it also has 8K of code cache. 2 different cache memories are used for data and code. Now after these processors, let us have some introduction to the buses. The buses are the group of lines used by the processor for communication with the memories or the IOs. If we talk about the buses, then each processor has 3 different set of buses, that is address bus, data bus and control bus. So we can see the block diagram, it is showing the address bus, it is showing the data bus and control bus. The address bus is unidirectional, it is responsible for identifying the memory or the IO with which processor wants to communication. Then data bus, it is responsible for the data transmission between the processor and the memory or between the processor and the IO. Obviously the data bus is bidirectional in nature. Then we have the control bus. The control bus is responsible for generating the various control signals. Now the various control signals are either memory read control signal, memory write control signal, IO read control signal or IO write control signal. Then we have this again a summarized comparison of the various processors having the detail of their data bus size, their address bus size and their memory size. In this table we have summarized all the processors starting from 8086 to this Pentium processors. In Pentium we have summarized like Pentium Pro, Pentium 2nd, 3rd. So this table shows the data bus width, the address bus width and the memory size of the various processors. So friends, today in this part of program we have discussed or we have seen the various processors, we have seen the comparative study of the various processors starting from the 4-bit processor, we have moved up to the 64-bit processor. We have discussed the various data bus size, the various address bus size, the various internal register size of the processors, how the first processor was working at a very low frequency and how the latest Pentium processor is working with the high frequency. We have seen that at the initial phase there was no concept of a pipelining. That means at the earlier stage the processor was processing by taking a single instruction at a time, decoding it and then executing it. Then with the advancement in 8086 we used 6 byte of prefetch queue and we used the pipelining concept, and with the advancement we came to the Pentium processors in which there is a 5 stage pipelining being used, and each stage is having a 32 bytes of queue. So we can see how the level of execution or the speed of execution has been raised from few microseconds to higher side. I hope you all have enjoyed this session of comparative study of the various processors. Thank you.